Hey Navajo Nighthawks, this is Module 5, Lesson 16. In this lesson, we are going to start working on adding and subtracting fractions with the same unit, so meaning the same denominator. So our objective is I will be able to use visual models to add and subtract two fractions with the same units. Those visual models, they could be area models, they could be number lines. In this lesson, we really just focus on the concept of what do we do when we add and subtract. And those visual models are always there to help us. Okay. So, kind of the basic concept that we want to make sure you guys understand when we are adding and subtracting fractions, our denominator stays the same. Okay. Especially if it's already the same denominator. So, if I'm working with tenths, my answer is going to be tenths. If I'm working with fourths, same thing. My answer is going to be in fourths. Our denominators don't change for a little while. We'll get to that. But for now, just remember our denominators stay the same. So really, when you think about it, it's basic addition and subtraction, but in a fraction form. Okay? So for example, if I had 3/5 minus 1/5, my fifth is going to stay the same, and I'm subtracting 3 minus 1. So it's just that basic subtraction. Well, what is 3 minus 1? 3 minus 1 is 2. So it's going to be 2/5. And if you think about that, we could write that as 2 as our numerator. Denominator is 5, 2/5. Pretty basic. This one's a kind of an easier lesson. Same thing with 5/5 minus 3/5. My fifths is going to stay the same, so we do 5 minus 3 is 2/5. 3/2 minus 2/2. Halves are 2, or denominator's 2. 3 minus 2 is 1, so this is 1/2. 6/4 minus 3/4. Fourths stay the same, so we're doing 6 minus 3. 6 minus 3 is 3, and my fourths stay there, so it's 3/4. Like I said, basic addition, basic subtraction, but we're doing it in fraction form. When we don't have common denominators, our denominators aren't the same, that's when we have to do a little bit more changing and moving. But in this lesson, all of our denominators will be the same. All right, so we've got 5/6 minus 3/6. I already know that I'm working with 6, so I can put my denominator as 6 and then do the subtraction of my numerators. 5 minus 3 gives me 2. My answer is 2/6. 6/8 minus 4/8. We can set it up. We already know that our denominator is going to be 8, and then we do the subtraction of our numerators. 6 minus 4 gives me 2. 2/8 is our answer. Easy peasy, right? Okay, we'll do a couple more together, and then we'll see what this looks like if we have mixed numbers as an answer. So 3/10 minus 3/10. You can enter this a couple times, right? I'm saying our denominator stays the same, so you could say, well, that's going to be, my denominator is 10. If you want to stay with the consistency of how we're doing it, 3 minus 3 is 0/10. Or you could just put 0 as your answer, because really if I have 0/10, I have 0. So you could have written that 0/10 or just 0. All right, 5/5 minus 4/5. We know our denominator is fifths. That's going to stay the same. Do our subtraction up top. 5 minus 4 is 1. So that's going to stay fifths, and now it is 1/5. So you can kind of think of it too, those pieces of the pie, right? If I have 5 pieces, they're still fifths. They're all fifths, and I have 5 of them. We ate 4 of them. That leaves me with 1, but it's still 1 of the fifths that I had. Okay, so it kind of help you make that connection. All right, I'm going to jump ahead a little bit to converting the difference to a mixed number. Okay, so I've talked about this a few times in our lessons. So we have 12 eighths minus 3 eighths. So notice our denominator stayed the same. 12 minus 3 gave us 9. So remember, if my numerator is larger than my denominator, that means I have an improper fraction. That means that is larger than 1. Okay, so if I have eighths, how many eighths do I need to make one whole? Remember, I need 8 eighths. So they're breaking this into a number bond. They're pulling out that 1. So they took 8 eighths away to make that one whole. 9 minus 8 leaves us with 1. So they converted 9 eighths, which is equal to 1, because that 8 eighths is equal to 1. So they rewrote it as 1 instead of 8 eighths, and we still had that 1 eighth. So 9 eighths is equal to 1 and 1 eighth. So they're converting that improper fraction to a mixed number. Okay? All right, let's do a couple of these ones together. The subtraction part is the same, so we do that first, okay? So first we know I'm going to stay in 6, and then 12 minus 5 is going to leave me with 7. Okay, so now you can see I have more than 1 because my numerator is larger than my denominator. So we're going to break that apart into a number bond. How many 6 do I need to make one whole? Whatever your denominator is, that's how many you need to make 1. Okay, so if my denominator is 6, I need 6 of those to make one whole. So I'm going to take 6 away, not take it away, but break it apart. So there's my 6. That's going to be my one whole. So 7 minus 6 gives us what? What fraction are we left with? We're left with 1/6. So we could rewrite our answer as 1. Okay, we know that that 6/6 is going to be equal to 1. And we still have 1/6. So our answer is equal to 1 and 1/6 is our mixed number. Okay, you guys see how we do that? All right, let's do another one. So we do our subtraction first. So we know that our denominator is going to stay 5. And then we can do the subtraction of 9 minus 3. 9 minus 3 gives us 6. We have that improper fraction. We have more than 1, right? Our denominator is 5, so we need 5 of those. We need 5 to make one whole. So we're going to pull out 5/5 and see what that leaves us with. Okay, so because I worked with fifths, I need 5 to make one whole. 6 minus 5 leaves us with 1. So we've got 5/5 and 1/5 to equal our 6/5. So we could say 6/5 is equal to 1, because that 5/5 we know is equal to 1. And we still had that 1/5. So our answer is 1 and 1/5. Okay. 9 minus 3 gave us 6. We took 5/5 out to make 1. And that left us with 1/5. So our improper fraction of 6/5 is equivalent to 1 and 1/5. All right, let's see if they get into addition. There we go. All right, so let's do some addition problems together. Very similar to subtraction. Our denominator is going to stay the same as long as they're the same. Okay, if both of my fractions have the same denominator, then it stays the same when we just add our numerator. So very similar to our subtraction. Okay, so we know we're working with eighths. that's going to stay eighths. And then we can add our numerators. 2 plus 5 gives us 7. So 2/5 plus, or 2/8, plus 5/8 is equal to 7/8. We have 4/12 plus 5/12. We know it's going to be 12ths. So we can set that up. And then we add our numerator. 4 plus 5 gives us 9. All right, so we will do, and then we're going to do the same thing like we did with our subtraction, right? If we do our adding, if we have an improper fraction, we just break it out into the number bond and rewrite it as that mixed number. So we'll do 2 of these together with adding, and then that'll be it for today. All right, so 4/4 plus 3/4. We know it's going to be fourths, so we keep it fourths. 4 plus 3 gives us 7/4. And then we can decompose, because we know that if I have fourths, 4 of those are going to be equal to 1. They kind of broke it up in their addition sentence with this one, because 4/4 is equal to 1. So 7 minus 4 is equal to 3. So if we could have just looked at this and said, well, that 4/4 is 1. So 1 plus 3/4 gives us 1 and 3/4. We kind of just rewrote what they did. That's all right. You can see it all come together. All right. So 4 plus 3 gave us 7. We took 4 of those out because we know that if I'm working with fourths, I need 4 of those to make 1. And I rewrote that one as 1, and then we still had 3/4. So we read this as 1 and 3/4 is equivalent to 7/4. All right. Last one. So we have common denominators. They are ninths. So we're going to stay ninths. And then we're going to add our numerators. 6 plus 6 gives us 12. So we have 12 ninths. How many ninths do I need to make 1? Well, if my denominator is 9, then I'm going to need 9 to make 1. So we're going to pull 9 ninths over here. 12 minus 9 leaves us with 3. So we're going to have 3 ninths over here. And then we can rewrite our answer as 1, because that 9 ninths is equal to 1 and 3 ninths. So 6 ninths plus 6 ninths gave us 12 ninths, which is equivalent to 1 and 3 ninths. All right, so hopefully that wasn't too fast for you. If I ever go too fast, you can always pause, rewind, watch a little bit more if you need to. But I wanted to make sure you could see subtraction and addition. So this will be our review for this week. Pop in to my office hours if you guys have any questions, okay? All right, great work today. We'll see you guys soon.